So, good morning. Screen share is visible.
Yes, sir.
Hi, sir.
Okay. So, last class we have discussed about this problem, and today we shall discuss some more problems on coplanar non-concurrent force system. So, now here, given problem for the non-concurrent coplanar system shown in figure, determine the magnitude, direction, and position of the resultant with respect to point A. So it has been asked in VTU exams, so August 2003. So here it is a non-concurrent force system. So we need to calculate the magnitude, direction, as well as position of the resultant of forces with reference to point A. Now here, so the resultant magnitude, direction, and position is required with respect to point A. So first you select the reference axis about point A. So point A becomes the origin of the reference axis. So let us select the x-axis like this and y-axis over point A. Now, first you find the sum of its horizontal component. Sum of its horizontal component, that is the forces which are parallel to x-axis. Now here, point A, you have a 100 Newton force acting towards negative direction, negative axis, along x-axis, and here at point C you have a 100 Newton force, and at point D you have a force of 100 root 2 Newton, so which is making an angle 45 degree with respect to the horizontal axis. Now we have to find the sum of the horizontal components, that is sigma f of x. So let us start from this point. So sigma f of x minus 100, next plus 100. So this goes off minus 100 plus 100 plus 100, and this force 100 root 2. So its x component is 100 root 2 cos 45. 100 root 2 cos 45 acting in the positive direction along x-axis. So hence sigma f of x will be minus 100 plus 100 and plus 100 root 2 cos 45. So now similarly sigma f of y is, so you have a force 200 Newton acting in the upward direction which is parallel to y-axis. So plus 200 and the resolution of this force is, its vertical component is minus 100 root 2 sin 45 acting in the downward direction. Minus root 2 sin 45 acting in the downward direction. So hence sigma f of x is plus 200 minus 100 root 2 sin 45. So sigma f of x is minus 100 plus 100 plus 100 plus 100 root 2 cos 45. So sigma f of y is plus 200 minus 100 root 2 sin 45. You can see here sigma f of x 100 minus 100 plus 100 root 2 cos 45, that is equal to 0. Sorry, 100 Newton. Sigma f of y, that is 200 minus 100 root 2 sin 45, that is equal to, so thereby the value of the resultant is about 141.421. So now we got the magnitude of the resultant as 141.421 Newton, and the direction of the resultant is nothing but sigma f of y divided by f of x. So theta is tan inverse sigma f of y by sigma f of x. So that is, I think we'll get it as 45 degrees. So 45 degrees. So the resultant acts in the first quadrant because both sigma f of x and f of y are positive. So the resultant is in the first quadrant, and this angle theta works out to be 45 degrees. So now we want the position of the resultant. Position of the resultant, that is the position of the resultant with respect to point A, is nothing but r into d. R into d is the moment of the resultant about point D, that is r into d. So that you need to find the distance d, and that should be equated to the sum of moment of all the forces with respect to point A. So r into d is equal to sigma me. Sigma me means the sum of the moment of all the forces with respect to point A. Now let us find the moment of all the forces with respect to point A. So now for this horizontal component, there is 100 Newton force, since it is acting along line AD. So r perpendicular distance is 0. So you can neglect this because it is acting along x-axis. So the perpendicular distance is 0, or else 100 into 0. Next, we shall consider this force 200 Newton. So it is acting in the upward direction. And if you project the line of action like this, it is acting like this. Correct? It is acting in the upward direction. And the perpendicular distance with respect to point A is 2 meters. The perpendicular distance is from the line of action of this force is 2 meters. And if you consider the moment, it creates an anti-clockwise moment with respect to point A. So hence, minus 200 into 0.2. Minus 200 into the perpendicular distance is 0.2. Next, if you consider this 100 Newton force, so it is acting like this, correct? It is acting along line BC, and the perpendicular distance is with respect to point A, it is 4 meter. And if you consider the moment, it creates a clockwise moment with respect to point A. That is force into the perpendicular distance. It creates a clockwise moment. So hence, sigma MA is equal to, that is, first is 100 into 0. Next is minus 200 into 2. So unmute ಮಾಡ್ಕೊಳ್ಳಿ. Mute ಮಾಡ್ಕೊಳ್ಳಿ ಯಾರಲ್ಲ sound. So next, sigma MA is 100 into 0. Next, minus 200 into 2. Minus 200 into 2. And this is 100 into 4. 100 into 4. It creates a clockwise moment. Now, if you resolve this for its horizontal component acts along x-axis. So hence, the moment is 0 because perpendicular distance with respect to point A is 0. Or else 100 root 2 cos 45 into 0. Next, its vertical component. You can see the vertical component is acting in the downward direction. That is minus, it is minus 100 root 2 sin 45. It is acting like this, 100 root 2 sin 45. And the perpendicular distance is 4 meter with respect to this point. From point B to point A, it is 4 meter. So this also creates a clockwise movement. This also creates a clockwise movement. That is 100 root 2 sin 45 into the perpendicular distance is 50. Mute ಮಾಡ್ಕೊಳ್ಳಿ. So now let us check some of the movements. Now sigma ME, you can see 100 into 0, 100 into 0. That is again 100 root 2 sin 45 into the perpendicular distance is 4, and the horizontal component 100, that is this one, 100 into 4. So sigma MA is 100 into 0 plus 100 root 2 sin 45 plus into 4 plus 100 into 4 minus 200 into 2. So on simplification, we get the sum of moments as 400 Newton meter. So the units are most important because if you don't write the units, just people simply write 400, it doesn't carry any meaning. So against the answer, you have to write the appropriate unit. The unit for moment is Newton meter. Now we want this D, that is R into D is equal to sigma MA. So D is equal to sigma MA divided by the resultant value, whatever the resultant value that you got as 100 root 2, that is 141.21. So thereby you get the distance position of the resultant as 2.82 meters. So once you get the position of the resultant, then you can calculate the values of x-intercept and y-intercept. So x-intercept is sigma MA divided by sigma f of y, and y-intercept is sigma MA divided by sigma f of x. So these are the values of x-intercept and y-intercept of the resultant. Now let us discuss one more problem. Now here, I will hide the solution part. Now here, find the magnitude, direction, and position of the resultant of forces with reference to point A of the forces as shown in figure. Now here you have a member of this shape, and here this is point A, and this is point B, and here you have a 200 Newton force acting, which makes an angle 60 degree with respect to the horizontal axis. And here from point C to point D, point C to point D, so you can see these half circles. You can see this half circle. So this is not nothing but it is the intensity of the load. It is the intensity of the load. That means the load is uniformly distributed. So whenever you find this half circle, it means this portion of the member is subjected to uniformly distributed load. Uniformly distributed load. That means the load is distributed uniformly throughout the length of the member. That is between point C and D. It is subjected to a uniformly distributed load. And the intensity of this load is given. That is 100 Newton meter. 100 Newton meter. Newton per meter. So it is called as uniformly distributed load. And the intensity is 100 Newton meter. Disturbing the class. So here it is subjected to a uniformly distributed load. So whenever you have this type of load, that is uniformly distributed load, you have to convert this uniformly distributed load to point load. Now here the intensity of the load is given 100 Newton per meter. 100 Newton per meter. Who is creating this nuisance in the class? I don't know, he has got some mental problem, I hope. So this is a uniformly distributed load and the intensity is given 100 Newton per meter. Now in such case, you have to convert this uniformly distributed load to point load like this. So in order to convert this uniformly distributed load to point load, you have to multiply, this is the intensity of the load, 100 Newton per meter into 1. So that means 100 Newton meter into 1 is 100 Newton only, because in the denominator you have meter. So when you multiply with the distance, so it is the meter gets cancelled. So it will be converted to point load, and this point load will act exactly at the center of this section, exactly at the center. That means between this center. So center is 0.5. It is 0.5 meter from point C and also 0.5 meter from point D. So it will act exactly at the center of this distance, that is about 0.5 meters from point C and 0.5 meters from point D. So in such case, you need to convert this uniformly distributed load to point load by multiplying the intensity with the distance. So it will be converted to point load. Now we shall proceed with the problem. So here from A to B, the distance is 1 meter, and from B to C, it is 1 meter, and from C to D, it is 1 meter. And this is point D, and you can call this point as E. So here at point E, you have a 500 Newton force, and this distance from D to E is 0.5 meters. And here at point A, you have a 100 Newton force. Now we need to calculate the magnitude, direction, and position of the resultant of the forces with respect to this point. So first select the reference axis about point A. So y-axis like this and x-axis like this. Now first is we need to find the sum of the horizontal components, sigma f of x. So here, so this is vertical. So here when you resolve this inclined force, its horizontal component will be minus 200 cos 60, minus 200 cos 60. And here it is acting vertically downwards, that is 100 Newton acting right at the midsection of this between CD. So it is also a vertical force. So here sigma f of x is minus 200 cos 60 plus 500. So you can see here 500 forces is acting parallel to the x-axis. Now sigma f of x is minus 200 cos 60 plus 500, that works out to be 400 Newton. Now sigma f of y, so since it is acting in the downward direction, minus 100 and minus 200 sine 60, it is also acting in the vertical direction. So minus 100, minus 200 sine 60, and again minus 100. So it is acting vertically downwards, minus 100. You can see here, minus 100, minus 100. So this is also minus 100 and minus 200 sine 60. So on simplification, we will get sigma f of y as minus 373.21 Newton, or either you can write minus, or in the bracket you can show the arrow in the vertical downward direction. So here sigma f of x is positive and sigma f of y is negative, hence the resultant lies in the fourth quadrant. So once you get this sigma f of x and sigma f of y, then you can calculate the magnitude of the resultant by using the expression. So thereby you get the magnitude of the resultant as 547.07 Newton. Now, once you find the magnitude, then next step is you need to find the direction of the resultant. It is tan theta is equal to sigma f of y by sigma f of x. So you get the value of theta as 43.02. You can neglect this sign. No need to take this sign because always resultant is a positive value. So theta is 43.02. That means the resultant is acting in the fourth quadrant, and which makes an angle 43.0 degree, 02 degree with respect to x-axis. Now we have calculated the magnitude of the resultant as well as the position of the resultant. So the next job is you need to find the position of the resultant with respect to point A. That is, the position of the resultant is nothing but r into d. The equation we need to use is r into d is equal to sigma ma. That is the sum of moments of all the forces with respect to point A. So r into d is equal to sigma ma. So first let us calculate sigma ma. Now one by one we shall consider. So for this 100 Newton force, since it is acting along point A, the perpendicular distance is 0. That is, it is 100 into 0, or else you can just neglect this. And the horizontal component of this 200 Newton force is minus 200 cos 60. It is also the perpendicular distance is 0. So hence you can neglect it, or minus 200 cos 60 into 0. Now the vertical component of this 200 Newton force is 200 sine 60, which is acting in the downward direction. And if you consider the moment of this vertical component, it is 200 sine 60 into the perpendicular distance is 1 meter, and it creates a clockwise movement. You can see it creates a clockwise movement. So hence sigma ma is equal to 100 into 0 minus 200 cos 60 into 0 plus 200 sine 60 into 1. And again you have converted this uniformly distributed load to point load, which is acting exactly at the center of CD, that is about 0.5 meter from C and 0.5 meter from D. So it is acting like here, it is acting in the downward direction. So 100 plus, we are considering the moment about this point, and this also creates a clockwise movement. It also creates a clockwise movement. That is 100 into 1 plus 1 plus 0.5. That is, the distance is 2.5 meter from the center of this CD to A, that is 2.5. So it also creates a clockwise movement. That is 100 into 0.25. Now we have been left with only this force. That is 200 Newton, 500 Newton force. Now if I project back, so it is acting right over here. So if you project this axis, it is acting like this. And the perpendicular distance from point A to point A, it is 0.5 meters. So this height is 0.5 meter. And when you consider the moment, it also creates a anti-clockwise movement with respect to point A, that is minus 500 into 0.5. So sigma ma is equal to 100 into 0 minus 200 cos 60 into 0 plus 200 sine 60 into 1 plus 100 into 2.5 minus 500 into 0.5. So now let us check the values of sigma ma. You can see here 200 sine 60 into 1 plus 100 into 2.5 minus 500 into 0.5, because we can neglect these two. This one and the horizontal component of this 200 Newton force. So thereby we will get the sigma ma is equal to 173.21 Newton meter. So the sum of moments is positive. So hence you can show the direction of the movement like this. So the sum of moments is positive. So once you calculate the sum of moments, so that is R into D is equal to sigma NA. So thereby we'll get the value of ds. I think that is here it is again D. There is a printing mistake because the sum of moments is 173.21, and if it is divided by the resultant value, it will be something like 0.23 something, because 173 divided by 540.
Your screen is not visible.
Hello, pardon? Somebody is having any doubt? So here there is a printing mistake here. So it should have been 173.21 divided by 547.07. So it works out to be 0.31 meter. So here make the correction. So it is 0.31 meter, and then you can calculate the x-intercept and y-intercept. That is about 0.464 meter and 0.433 meter. So we know the magnitude of the resultant and also the direction of the resultant, and we got the position of the resultant and also the x and y-intercept of the resultant. Now you can see here the resultant is acting in the fourth quadrant, and it makes an angle 43.02 degree with respect to x-axis. Now next we have one more typical problem wherein a bracket is subjected to 5 forces and a couple as shown in figure. Determine the magnitude, direction and the line of action of the resultant. Line of action of the resultant is nothing but it is the position of the resultant. So here we need to find the magnitude, direction and the position of the resultant with respect to point A. Now here there are 5 forces acting. So at point A you have a force of 5 kilonewton, and at point B, let us call this point as point B, you have a force of 5 kilonewton. Again at point C, so here you have a 6 kilonewton force acting, and this distance is 10 centimeter. So here the distances are given in centimeters. You can convert it into meters. So this is 0.15, this is 0.15, and this height is 0.1 meter. And so let us call this point as A, B, C. And you can see at point D, already you have a couple that is already in existing moment. That means the force has been converted into moment. That means you can see the unit here. It is 10 kilonewton centimeter. So the unit of moment is either Newton meter or kilonewton meter. So here you can see this arc. You can see this arc. So at point D, already you have an existing moment. It is already an existing moment. Now again, if you consider this point as E, at point E, you have a 6 kilonewton force acting, which makes an angle 30 degree with respect to horizontal axis. Again, you can call this point as E. At point E, again, you have a 8 kilonewton force, which makes an angle 45 degree with respect to horizontal axis. And from the distance from point E to point F, so A, B, you can call this point as C, this point as D, this point as E, and this point as F. So this distance is again 10 centimeter, or you can take it as 0.1 meter. Now we need to find the magnitude, direction and position of the resultant, and also the x-intercept and y-intercept of the resultant with respect to point A. Now let us, we'll start with the basic. So select the reference axis about point A, y-axis, and this is x-axis. Now next is sigma f of x. So find the sum of the horizontal components. So let us start one by one. So here, this is the vertical component, vertical force, and here you have a 6 kilonewton force, which is parallel to x-axis. So sigma f of x is plus 6. It is acting in the positive direction, plus 6. You should not take this because it is a moment. It is not a force, correct? Only we are summing all the forces which are parallel to x-axis. That is sigma f of x is 6 kilonewton. And if you resolve this force, its horizontal component is minus 6 cos 30. So sigma f of x is 6 minus 6 cos 30. Again, you have a force here. 8 kilonewton, and the angle is 45 degrees. Now, this force is acting in the second quadrant. So you can, if you project this force, it is acting in the second quadrant. So in the second quadrant, the x component of the force is minus 8 cos 45. The x component is minus 8 cos 45. So sigma f of x is 6 minus 6 cos 30 minus 8 cos 45. Now similarly, sigma f of y is plus 5 minus 5. Plus 5 minus 5, and if you resolve this, its vertical component is minus 6 sin 30 acting in the downward direction, minus 6 sin 30, and if you resolve this force, its vertical component is plus 8 sin 45. Now let us check sigma f of x. You can see 6 minus 6 cos 30 minus 8 cos 45. So it works out to be minus 4.853 kilonewton. So that means it is negative. So in the bracket you can show the arrow in the negative direction. And sigma f of y, that is plus 5 minus 5 plus 5 minus 5. You can see 5 minus 6 sin 30 plus 8 sin 45 minus 5. So on simplification, you get sigma f of y as 2.656 kilonewton. So then you can find the magnitude of the resultant. So by using this expression, you'll get it as 5.532 kilonewton. Now here, sigma f of y is negative and sigma f of x is negative. Sigma f of x is negative and sigma f of y is positive. Hence, the resultant lies in which quadrant? That is, it lies in the which quadrant? I have a question for you.
Third quadrant.
Sigma f of x is negative and sigma f of y is positive. The resultant acts in the second quadrant. It acts in the second quadrant. So now you know the magnitude of the resultant. So once you know the magnitude of the resultant, you can find the direction of the resultant. That is theta is equal to tan inverse sigma f of y by f of x. So it works out to be 28.69 degrees. So the resultant acts in the second quadrant. Now we know the magnitude of the resultant and also the direction of the resultant, and we need the position of the resultant with respect to point A. So in order to calculate the position of the resultant with respect to point A, so we need to take the moment of all the forces with respect to point A, that is R into D is equal to sigma MA. So let us find sigma MA. So for this force, the perpendicular distance is 0 since it is acting along point A. Next you consider this. This is 5 Newton, 5 into 0.15 or 15 centimeters. So 5 into 15 centimeter, it creates a clockwise moment. Next you have a 6 Newton force. So somewhere it is acting like this, correct, in the horizontal direction. And 6 Newton force, this height is 0.1 with respect to the axis of the, that is line, x-axis. This distance is 0.1. So we shall take sigma MA, that is 5 into 0.15, 6 into 0.1. And now we need to consider this because this is an already existing moment. The intensity is, the magnitude is 10 kilonewtons centimeter. So 5 into 15 centimeter, 6 into 10 centimeter, plus you need not have to multiply with the distance, because if you multiply with the distance, it becomes kilonewton centimeter square. Already you have a couple or a moment here. Directly take its value depending on its direction. Now here it is clockwise. If it would have been like this, you have to take it as minus. Now here it is creating a positive moment. So 5 into 15 centimeter, 6 into 10 centimeter plus 10. Next, for the horizontal component of this force, it is acting along x-axis, no need to take. And for the vertical component, 6 sin 30 into that is 45 centimeter with respect to this point. So 6 sine 30 into 0.45 meter or 45 centimeter. Now this one. So here the x component is in the negative direction like this. It is 8 cos 45 and this distance is how much? It is 0.1 meter or 10 centimeter. So minus, so this creates a clockwise movement, correct? When you take this force with respect to this point, it is going to create a clockwise movement. So that is 8 cos 45 into 1. Next, if you consider the vertical component of this force, that is 8 sine 45, it creates an anti-clockwise movement with respect to this point. So the distance is 0.45 meter. So sigma MA is equal to 5 into 15 centimeter, 6 into 10 centimeter plus 10 plus 6 sine 30 into 45 centimeter. Next plus 8 cos 45 into 10 centimeter. Next minus 8 sine 45 into 45 centimeter. So now let us check. It's also given in centimeter. That is, you can see here 5 into 15, correct? 5 into 15 plus 6 into 10 plus 6 sine 30 into 45 plus 8 cos 45 into 10 minus 8 sine 45 into 45 plus 10. So this 10 is nothing but it is the already existing moment acting at this point. So thereby you'll get sigma MA is equal to 82 kilonewton centimeter. Once you get the sigma MA, R into D is equal to sigma MA, thereby you get the position of the resultant as 14.825 centimeter. So then you can calculate the values of x-intercept and y-intercept. So the time is running out. So I'll be ending this session. So we shall meet on Tuesday. So till then, have a nice day. Thank you. Goodbye. Any doubts? Hello? Is it clear? So on Tuesday, we shall solve some more problems on non-concurrent force system. I think your first session starts from 2nd of next month, correct? Okay. See, I request all of you to mark attendance only once. I don't know, some students are marking twice or thrice. I don't know what is the mindset. It becomes very problem for us to count, and then later on, people complain that I get attendance absent in jams. See here, the number of participants are 58, and the people who have marked their attendance in chat box is 78. I don't know the reason for this. They're all technical students, professional students. So again, I request only once you mark your attendance, it's okay. See here, the number of participants are 59, and the people who have put their attendance in the chat box is 78. I don't know what is the problem with you guys. Anyway.